Today we are going to make Claude read an IFC model and turn it into a price BOQ completely free of cost. This will only take $20 Claude code subscription and you have to bring your own rate library. We're going to touch on this later on in the video, but this skill is completely open source. It's completely free of cost to use. You just have to clone it and install it in your Claude. And this skill basically runs in 3 stages, and we're going to understand the entire backend of how this skill is actually performing. So we will have an idea and confidence in using this skill, and then I'm going to run it on the Claude on a real IFC model as well, so you can see it performing on real life scenarios. I'm Hamza Jabbar. I'm an AI construction automation specialist. We have more than 40 plus AI deployments across construction firms globally. And we recently helped a TB firm save 17 hours a week through 4D BIM automation as well. So let's get into the video and see this skill and understand what this skill does and see it in action. So basically, as I said, this is completely free of cost. I will link the repo in the description. You could just copy it, clone it, and install it. There's an entire detailed guide also available on how to do it. So let's just move into the understanding of the backend of how this skill is actually performing. So this skill is based on 3 stages, right? This is a 3 stage skill, and basically what the 3 stage skill is, the very first stage starts with, if you understand, if I summarize the entire skill, it's model IFC. Basically, you ingest your IFC model into Claude, right? Once you upload it into the Claude will extract all the quantities, and once it is extracted, it will classify every element, and then it will perform in price POQ. So let's break it down step by step. IFC models as compared to PDF are kind of easier to perform quantity takeoff on, because IFC models, whenever you extract the IFC model, it comes with the raw physical element, right? Like IFC wall, IFC columns, with codes like IFC pipe, right? So these are the elements that Claude can easily read and easily extract these, right? So these are physical, these are solid elements, right? But on the other hand, on PDF, it's really hard to like detect each element, and you have to train in custom AI model, and it's a lot of back and forth, and the drawing has to be vector and so on, right? But in IFC case it's not that difficult, because whenever you export it through Revit or ArchiCAD, you export the raw physical element as well. So, and then we extract the quantities, and then there is classify element. Now what does it mean by classify element is that which format code are you using. Right now this skill only work for CSI MasterFormat code. It does not work for NRM2, like, which is a new kit, because NRM2 is really difficult to train the AI on and perform the quantity takeoff. It's possible, but you have to train the AI, because like for example, you perform the quantity takeoff and you get a certain amount of volume, but then if you will apply the NRM2 code, NRM2 obligations on that, the volume can then differ. Like it could increase or either it could decrease depending upon the NRM2 accordance, right? And it is really difficult as compared to CSI MasterFormat code, because there's a lot of obligation and rules that you have to follow. So that's why NRM2 is not included in that. But if you want to make the skill more customizable and scalable for your own workflows, or for NRM2 accordance, you can reach out to me directly. Anyways, moving forward, but it will work perfectly in CSI MasterFormat code. So we have accept model, we give it to model, we extract the quantities, we classify, and then we price the final vehicle. So this price part is basically you bring your own rate. Every construction firm has its own internal rates. Right now, the skill that I will run is, it will use my RSMeans 2014 rate library, because that was the only one I could find, and that was in vector condition. So Claude easily extracted all that information, but uh, I will show you my rate library as well. And in the GitHub repo README, there is an entire uh, section telling you documentation, basically telling you how to perform, how to prepare your own rate library. Anyway, so you have to prepare your entire rate library, and then you will get the price POQ. First of all, the stage one is extraction, reading the model. So basically, you will upload the Revit model. It will read every physical element. It will extract all the physical with real physical quantities, like your length, your meter, volume, right? And it basically reads unit definitions per measure. So for example, if your length is in millimeter and your volume is in cubic meters, so what it does, it basically handles it correctly rather than it presses down, right? Then Moving forward, if the quantities are missing, because obviously IFC model is messy, the data is messy, and not all the data is basically extracted from the IFC model. So the thing with this is that the analogy that I came up with this is that the Claude then fall back to geometry. Now, geometry is a low confidence, it's not really high confidence, because it basically requires some mathematical or 3D meshing calculation that public models are not that good at. So that's why we have run like Python scripting behind it to make it how do I say, make it reasonable, make it like and that's why it's basically flagged as low, so that the estimator or you can review it that if it's right or not. So solid elements for like slabs and walls, it will go to 3D mesh calculation, and for MEP elements, it will go for excess center line math calculation for like ducts, pipes, and MEP elements, right? And it's just a fallback if the quantities cannot be derived from physical elements, right? If there are no quantities to be derived from, so that's why it falls back to geometry. And again, it's a low confidence flag, but still a really good fallback. And due to custom coding, it's basically, as I said before, it's reasonable. Geometry calculation is reasonable. Anyways, then moving forward, then we have got our CSI format classification. Basically, what it does is that it have more than 20 plus element classes, right? It covers your walls, it covers your columns, it covers your footings, beams, doors, like 20 plus elements are in this skill that it could classify these elements, right? So this is pretty amazing. Then basically it goes deeper as well, like concrete gets subtyped by element, like footings, walls, steel get auto extracted from sections by section size from element name, and then we have slabs, which basically auto detect as an on grade versus suspended. So basically it's really trained, and it's basically does really deep classification. It's not some like in Claude wrapper. It's basically I have to spend a lot of time to actually come up with this, and this is basic. If you keep trying and if you keep using it, you will actually see it yourself that it's really good, and it gets better and better after learning the past mistakes. Then we have stage 3, which is our finally pricing. Now basically in this, the entire elements get joined to our rate library, right? As you can see, rates are applied. Now you have to bring your own rate library, and as I said before, you will find the documentation, and you probably will have your own rates as well. Every firm has its own rates, doesn't matter whichever source you're bringing, it will be an Excel format. You can just upload it into Claude, and you will be good to go. So I will show you the folder structure as well, how you have to prepare your folder structure when running this skill. Now the question here is why we cannot use just Revit schedule. As you know, when you export the IFC file, uh, because inside Revit, if you have a Revit model, then this skill is useless, because, well, I will not say this skill is useless because but it's really easy to perform quantity takeoff because you have all the database, you have got all the elements available in there, so it's really easy to perform quantity takeoff. But still, you do not get it, you do not classify it, right? You cannot classify it in CSI master format code. If you take that example, you cannot price it, right? So these are the two things that you still lose time. And again, if you export the Revit, if you export what I would say, if you export the model from the Revit, let's just say the schedule is not exported with Revit, right? Schedule only work inside Revit. So you only get the raw physical element. That's it. You do not get the schedule. So that's why uh, you cannot just use Revit schedule. That was just an FAQ question that I have to answer because I received it on LinkedIn. Anyway, so the full picture is extract, classify, and price. This is the entire summary of the skill. Basically, you got the model, you will extract quantities, you will classify it, and you will price it. And that's the entire uh, back end of the entire skill, how it works, and hopefully you get it as well. Now, let me show you first how the folder structure will look like. So this is my IFC BOQ folder. You will prepare 4 things. Once you will clone it, you will already get this folder pre-built. So all you have to do is put your files into these folders. So inputs will have our Revit folder, right? Our outputs will be the price BOQ that you will get, right? So I have already run one time the skill, so it has already performed the price output here. So you can see I've already run the price BOQ. I'll show you in a minute. Then we have got our rates, right? This is a rate library, the rate library template or rate library that you want Claude to have an access. And then finally, we have our templates. Templates mean the branded BOQ template. Obviously, every firm has a different branded BOQ template. So if you want to perform BOQ on your branded template, you could just upload a reference and Claude will copy it exactly, right? Apples to apples. Now, let me just show you the rate library so you have a kind of an idea of what I'm talking about. So this is the entire rate library. As you can see, forget this master format. So basically, this is the classification. Once you will upload your rate library, once you will run this skill, Claude will basically classify each element and will uh, apply the bill tag on each of the elements. So you can see we have got our wall, we have got our slab on grade, we have got structural steel. So all these rates are taken from the RSMean 2024, and you can see the classification as well. You can see the numbers, division numbers, everything, right? And you can see the 1.55 factor is basically the inflation factor. I'm using 2014, so I asked Claude to perform for 2025, so it basically does that factor. But when you will run it, I have excluded in the repo, so you will not get this factor. So this is basically the folder and the rate library. Now just quickly let's go and run this skill. Okay, so as you can see here, give me a moment, my Claude is not working. Okay, just give me a moment. Okay, let me just try opening it again. Okay, so as you can see, we are going to use this Revit model, right? We are going to be using this Revit model, right? I know it's still really small, but just for the sake of video, I wanted to perform it on a really small scale so that you could see it live in action. So hopefully you have seen it. I will just close it down because being really heavy on my Claude. What I'm gonna do is I'm gonna perform the skill. And okay, okay, I'm sorry. So it's basically BOQ from IFC, and I'm gonna just say run the BOQ on the Revit structure. You can find the model rate library in my, just point to the folder that you have got on, like I will just say in my desktop folder named IFC BOQ. Right, I guess it's good to go. Opus 4.8, and I'm just gonna press enter, and it's going to start running. Let's just see the model again. So basically, this is the model, right? Hopefully, you guys can see it. I'm just gonna close it down. Okay, so we are apparently done with the. Let me check my mic. Okay, it's on. Anyway, okay, so we're done with the price BQ, and it was talking really fast because I think the model was small or that I have already run it. So as you can see here, extract done 454 elements. All right. Okay. We have got the live formula that it implemented, which means directly from quantity times rate. Estimated grant 376,000 currency your rate library. Per your rate library means if I would have uploaded, let's just say RS 2026 means rate library, it would have been significantly different, right? Zero. Okay, so I didn't discuss the flags that I wanted to discuss. Let's discuss it uh, later on. But the zero rate not, basically, let's just discuss it right now. There are three flags. There is high, low, and rate not found. High means that all the quantities were derived, no fallback geometry. All the quantities were derived, right? No quantities were missing, and all the rates of these quantities were fine. Secondly, low flag means that rate was found for the quantity, but the quantity was derived from geometry fallback. There was no physical quantity available. Thirdly, the rate not found means that the quantity was derived, but the rate was not found of that specific element. That means that the element was not classified or the element has no sorry, not classified, not quantified, right? The rate was not available for that element in your specific rate library, so the flag would be rate not found. Hopefully that makes sense. Okay, so as you can see, IFC beam, the code that I was talking about, see, that's why it's really easier as compared to PDF takeoff, because there is all these elements come with these codes, IFC column, IFC beam, that these vector codes that Claude can easily extract and pull out of the IFC model. So we have got IFC column 30, IFC beams 370, footings we have 4, member 2, stair 1, stair 4. Okay, makes sense. Then we have confidence 401, and we have confidence low 53. Okay, 53 because those will be geometry fallback. Okay, data quality 5, 9 elements at a quantity or unit auto corrected. Okay, so that's why I told you about it. It measures unit definition per measure, it reads unit definition per measure. That means that auto correction will be done, and that's what I meant when I explained it earlier. See, millimeter and meter mismatch in the Revit export, so it got auto corrected. So basically the skill handles it correctly because it beats unit definition per measure. Reconciled against geometry. One element had no quantity at all, flagged low, like verified by hand, like not even by geometry. That element could not be. That element had no quantity at all, even with geometry, fallback geometry. So you have to verify it. And then for the 42 element fell back to geometry derived quantities, which is why they low in low to medium buckets. Okay, so there. Okay, we're done with that. Let me just quickly open this. Where is God? Okay, so it's in Revit structure price BOQ output. Let me just go here. We just quickly open it. And here, um, I don't know which one it is. Output file. I don't know where it has saved this file. Just quickly. Okay, this one. Okay, I just forgot today is 17. Anyway, let's just do this. I opened it, and once it got open and we could actually, okay, let's just see if it actually performed the right or not. I don't know why it's not opening it. Let me just try it again. My god, what is happening? Okay, this is the one. Okay, Revit structural price view. Okay, this is the one, and you can see this is ACME quantity server because that was in my branded template. Okay, so you can see the classification, division 3 concrete. So we will find all the concrete elements here. uh, as you can see, this is 790.6 for the wall, right? Let me just quickly show you the wall rating in my rate library. um, okay, here you go, concrete wall, and the price is 790.66, right? Basic wall, division concrete, 790.66. You can see, you could check it with your rate library, and you could cross check it, and I just showed you that it is actually right, right? And why this is high? Because this was not derived from geometry, it was available inside the Revit model in the physical element, raw element, and you can see the pricing here, and it actually matches, so it's not hallucinated. Then we have got the, okay, so from geometry means that it was, if it's a physical element, let's just say it will, if it's a physical element, it was grabbed by 3D meshing calculation, right? If it was MEP element, it was from axis center alignment. Anyways, it's geometry, it's low. As you can see, verify, we have got high, we have got another division, metal. So this is the classification that I was talking about, right? High, then again geometry, high, we've got the units, we've got the units, we've got the quantity. As you can see here, we've got the quantity, we've got the unit rates, we've got the amount, and yep, and we've got the grand total and division, thermal and moisture protection. So this model has 454 elements, and you can see this is the final BOQ that we got. Hopefully you like the video and do try out the scale. Wherever you search, just let me know. And if you want any help, just reach out to me in comments, or you can also reach out to me on LinkedIn. Uh, I will share my LinkedIn also in there. If you are from a construction firm and if you want to customize it for your own workflows and you want to scale it in your workflows and for your internal and have to basically make it internally and don't want to upload your data on public models, or basically want to custom train so it actually accuracy significantly improve, you can reach out to me on my calendar. You can schedule a call. I will link that in the description as well. And that was all about it. I will see you in the next one, hopefully.